Here we're going to look at question 34 of the ENGAA 2018 paper. In this question, we're given the following scenario. We have 4 blocks, all of different mass, connected by inextensible rods. The end block is pulled by a force of 30 newtons. The question asks us, what is the tension between X and Y? To go about answering this question, the first thing we should notice is that there's no frictional force on the blocks, and therefore they do have a resultant force of 30 newtons on them. This means that the blocks are all going to be accelerating. Since we want to find the tension between X and Y, it means we want to find the force which is accelerating W and X forwards. Therefore, we're probably going to have to find out their acceleration. Now, since the blocks are all connected by inextensible rods, then they're all going to have to move together. So the acceleration of each of the blocks is going to be the same. So our 30 Newton force is pulling all of these blocks together. It doesn't mean that there's a 30 Newton force on each block. That would be different. In that case, then there'd be 120 Newtons in total pulling it. It'd be 30 on each. Instead, this 30 Newtons is going to be shared between each of the blocks. This 30 Newtons is just accelerating the whole system, so we can go ahead and consider this whole system together. What I've done here is accumulate all of the blocks together into one big block with a mass of 15 kilograms. By doing this, we can go ahead and use Newton's second law to calculate the acceleration of the system. So the force is just going to be the total force on the block, on the system, which is 30 newtons, divided by the total mass of the system, which is going to be 30 divided by 15, so 2 meters per second squared. Then this acceleration is the acceleration of the whole system, and therefore is the acceleration of each mass, since this masses all accelerate at the same rate. So since we know the acceleration of each of the masses, we can go ahead and try and find the force which is accelerating the masses W and X. So the tension is going to be acting here on the X block. It'll also be acting backwards on the Y block, but we'll come to that in a moment. So if we look at just our W and X block together, then we see that this force tension is acting exactly like the 30 newtons was on the whole system. But this tension is only acting on W and X here, in this direction. So the acceleration of our whole system here is being governed by this tension. Therefore, let's go ahead and condense our W and X into one smaller system. So we have a tension force acting on a combined system of W and X, and the whole system is still accelerating at 2 meters per second squared. The mass of this whole system is just going to be the mass of the 2 blocks added together, giving us 7 kilograms. And then we can go ahead and use Newton's second law again, telling us that the tension is equal to the mass of the system multiplied by its acceleration. Since we know the acceleration of the system is just 2 meters per second squared, and the mass of the W and X system is 7 kilograms, then the tension pulling the system is going to be just 14 newtons. Now, the tension going from the Y block backwards is going to be exactly the same, which is 14 newtons. And we could have found the tension in that direction as well by considering the Y and Z system. Now, in this case, there's a force pulling the blocks forwards of 30 newtons and a force pulling back of the tension. So, in this case, we could have set up Newton's second law as well, with the resultant force being 30 newtons take away our tension, equaling the total mass of the system multiplied by the acceleration of this system, which again would just be 2 meters per second squared. This would give us the same answer of 14 newtons, which corresponds to answer D.